Okay, this is an introduction to pre-calculus course as I'm going to approach this section this semester. Few unique characteristics of this course. Okay, in this course, we're not going to build the course on arithmetic and algebra. We're going to build it on pictures and shapes. Now, that doesn't mean we're not going to do arithmetic and algebra. We're going to do plenty of arithmetic and algebra. And while we're studying the shapes, we're going to develop the arithmetic and algebra. The reason for that is that many people, especially people are placing themselves in these courses without any placement tests, we find that many people, a lot of the people in the course, probably a majority, don't really have the arithmetic and algebra skills they need to succeed in the course. So we start with pictures and shapes that everybody can probably understand. And then we work along the arithmetic and algebra for a couple of weeks until we have enough of a handle on the arithmetic and algebra to do the arithmetic and algebra that's associated with these shapes. Now, you won't totally understand what I'm talking about until we actually get into it. Let's look at a few principles in this course. Okay, we start with shapes and sketches. That avoids hangups with arithmetic and algebra because majority of the typical incoming pre-calculus course has a lot of hangups with arithmetic and algebra. We'll get over those hangups in a couple of weeks, and we will, if you do all the work and do it as we recommend, okay? You can always use ChatGPT to get the right answers, but you're going to come into class and you're going to have a quiz. And if you didn't learn how to do this stuff by mimicking what ChatGPT tells you, you're not going to pass the quizzes. And you're going to get immediate feedback that'll tell you, hey, you need to change your approach a little bit. We'll work on that. Okay. Now, as I said, we'll review the arithmetic and algebra on the side while we're learning to deal with these shapes. Okay. In this course, we do almost nothing that requires a calculator. Calculator is a black box. You do your arithmetic on the calculator, you take the answer and you hope it's right, but you don't really understand how you got it unless you do the arithmetic yourself. Of course, that means we keep the arithmetic pretty simple and pretty basic. If you have to take the square root of a number that doesn't have a perfect square, well, you are stuck with a calculator. So when we take square roots, but we're going to be doing it with perfect squares of integers, okay, like 25 or 36 or 1 over 49, okay? And that one might throw you a little bit, but we'll deal with it. Okay, so we do almost nothing that requires a calculator. We don't construct our graphs with a calculator. We construct our graphs with our hands by sketching them because that reinforces what you're doing, causes you to think, forces you to think about what's going on, okay? And it's also easier than doing a bunch of arithmetic and algebra. You'll have to do it eventually, but we don't want to start out having to do all that, okay? And we're not going to use a calculator to construct our graphs. You might have done that, okay? Now, it doesn't mean the calculator can't be handy, it can't be helpful. Once you've constructed your graphs by hand and documented how you constructed them, it can be kind of fun to go to your graphing calculator or online Desmos, an online application or other applications, and sketch, let the computer sketch the thing for you and see how it agrees with what you did. If it doesn't agree, that means the computer probably messed up. Well, no, it probably means that you messed up. But maybe you messed up in the way you entered in the computer. Well, we have to deal with that. Okay, so let's not worry about that. But there is a place for the calculator, but we're not going to emphasize it. We do almost nothing that requires a calculator. There are things you can do with the calculator after you've done it in the way we do it by hand. And like I say, I'm not going to ask you to take the square root of 793 by hand. It's not the perfect square of an integer. You can't even write the thing down completely. It keeps going on forever. Okay, well, that aside, we do almost nothing that requires a calculator. Okay, now, big deal here. Matter of fact, this is such a big deal. I try to keep this reddish chalk and hold it back for big deals. This is a big deal. Do it. Don't sit back and just watch it. You don't learn anything by sitting back and just watching it. You might be watching videos, and I hope you don't spend too much time watching videos on YouTube or TikTok or whatever. But if you're watching, you're usually passive. You don't learn much by passive interaction. And it's not even hard, it's hardly even interaction, but I guess it sort of is. Okay, do it. You don't sit back and watch it. If I say sketch this thing, sketch the darn thing. If I say write out your steps, write out your steps. Excuse me, I haven't been talking that much this summer. I'm getting a little hoarse already. Okay. Anyhow, do it. Don't sit back and watch it. And another big deal, I guess, this needs to be served, is check your work. Don't just do it and hope that it's right. Do it and find out whether you did it right or not by checking it. If your check doesn't work, it means you screwed something up and you have immediate feedback. And while your head is still in the situation, in the problem, you can go back and try to fix it. That's how you learn. Okay? You don't learn by writing down a wrong answer and going on. You learn if you write down a wrong answer by figuring out why it's wrong. Now you can't always figure that out, and that's a place where you need to be able to ask questions, and we'll give you plenty of chance to do that. But get the immediate feedback by checking your work. Okay. Now the course, let's just get into the course, okay? The course is built on roughly 10 shapes. You see a couple of them over here, and we'll talk about this in just a second. Okay, we start with 3 of these shapes, and the 3 of them are on this board here that we'll talk about in just a minute. These shapes represent what we call functions. Now you might, depending on your background, and many of you I'm sure do understand something about functions, maybe quite a bit about functions. If you have a really good Algebra 2 class, but these days it's difficult because people are somewhat behind because of COVID, and it's very difficult in those prerequisite courses to do everything that those courses ideally will do. So this is something that might not have been covered as much as it should have been. So we're going to spend plenty of time trying to understand it. If you already understand it, bear with us. We're going to challenge you before too long. Okay. Okay. And if you don't know it, well, we'll generally get into it, but kind of quickly, you're going to have to do a lot of work. If you don't have this background at the beginning, so you have something to build on so we can get through the course. And we aren't going to compromise on the content of the course. We're going to cover the content in a way that I think will build as much success and as much understanding as possible. Okay, we'll start by learning to sketch these shapes. You see them there, you kind of see what they look like. And we're going to do that without doing any calculations because, like I said, trying to avoid hangups with arithmetic and algebra, and their calculations involve these simple shapes with fractions and exponents that people typically get. A large proportion of an incoming pre-calculus class is typically unable to do very well at the beginning. We're going to try to fix that right at the beginning. Okay, but we want to be able to construct these shapes without having to do the calculations. Then when we do the calculation, we'll say, oh yeah, now we see why we constructed the shapes the way we did. Okay, just real quickly, and then we're going to actually talk about how to construct them. I generally construct the shapes inside of a square. And there are reasons for that to make sure you see the whole board. Okay, there are reasons for that. And you'll see as we go on. Okay, one of my shapes, and this is called a parabola. Okay, looks like this. Another one of the shapes, this is actually kind of the simplest shape, but it's extremely important. Matter of fact, this is an exponential function, a graph of an exponential function. And you're going to learn what the characteristics of an exponential function are before you even start calculating with it. Okay, so it kind of looks like this. I didn't draw it really well. It's a little too, it should be steeper right here. Okay, and it doesn't quite have the right shape, but it's pretty close. You kind of get the idea. And when we construct it, we'll learn how to make a better graph than I did. And we'll also learn how to make a better graph of this parabola than I did, because the graph of a parabola should be symmetric about center. And I've sketched this thing so that the center line is right here. Okay. And you see that the left edge of the square, the graph is closer to the left edge than it is at the right edge. It's not symmetric. It's not bad, but it's not a really good graph. And it's a little flatter over here than it is over here, down near the red dot that I drew in the middle of the bottom edge. Okay. Now, since I mentioned the red dot, there's a red dot in the middle of the bottom edge of the square here, and there's a red dot in the middle of the bottom edge of the square here. Here there's a red dot, but it's right in the middle of the square. And this graph looks a little different than these. In some ways, it's a little more complicated. Two things about the graph. One, it's not totally vertical right here. It's not totally horizontal right here. Okay, same here and here. It also, if we draw a vertical dotted line through the red dot here and a horizontal dotted line through the red dot here, you can think of that as a y-axis and an x-axis if you wish. We don't get to the y-axis. This point is a little bit to the right of this vertical line. This point is a little bit to the left of this vertical line. This point is a little above this horizontal line. This point is a little below the horizontal line. And if you do it right, and we're going to see how to do it, you're going to find that the distance that this point is to the right of the vertical line, and the distance this is to the left of the vertical line are the same. And the distance this is above the vertical line is the same as the distance this is to the right of the vertical line, and the distance this is below the vertical line. In other words, this distance, this distance, this distance, and this distance are all the same. Okay, now we'll see what those distances are. Now, if you've had some background, we'll just mention, we can throw these onto an X and Y coordinate axes, and the X and Y coordinate axes for what we call the toolkit functions always go through the red dot. Okay. Now, you don't need to know the rest of the details. If you see details here that make sense to you, that's fine. But really, you're just looking at these shapes. And right now, you should sit down and sketch yourself 3 squares and see if you can sketch shapes that look kind of like this. Okay. You might do it well, you might not. Don't worry about it. Do your best and then compare and see how you match up. We're going to learn to construct them in just a minute. Okay, well, that's kind of an overview of how we're going to begin the course. And there's some implications in what we've said already that carry throughout the whole course.